Good morning, viewers. Good morning, friends, and good morning, colleagues, and the industry veterans. I would say this is Rajiv Kulkarni from Global Electronics, and Global Electronics welcomes you for their launching session of this fantastic platform that we are bringing in to talk about global electronics manufacturing. What are the manufacturing challenges that we face in today's fast-paced environment of manufacturing, and where we talk about the AI, where we talk about the innovative ideas, where we talk about so many different designing aspects of manufacturing the product. So this global electronics is exclusively brought to you all just to get the knowledge spread and the knowledge made awareness to you all about electronics manufacturing. Electronics manufacturing, when we talk, we think it's a simple process, but it's not, because the basic manufacturing begins, or the product needs the designing aspect. Yes. So if you don't design, there is no product. If there is no design, if there is no product, and how do you have a product? You have to have a manufacturing activities. You have to have a manufacturing or a smart manufacturing factory. In today's terminology, we call it. And in order to understand all these fine details, the nitty-gritty of electronics manufacturing, Global Electronics brings you the best in the industries, the best expertise talks in the industries. And we are starting, that is today, October 25th, 2024. This is your host, Rajiv Kulkarni, bringing you every week, every Friday, this particular show, only for you to get some kind of an awareness about how electronics manufacturing takes place. You're free to reach out to me at 972-365-7048 or globalelectronics1234@gmail.com. With that said, I want to definitely thank the audience who are going to log in, or who have logged in, and plus definitely Sandeep Sadanandapa, who is my great technical support guru to set this studio up. Thank you, Sandeep. And he runs a company called A&V Perspective, and he's based out in Bangalore. Today, we have a special guest. As I mentioned, in order to have a product, you need to design. And design is the most important aspect of any product. And with that said, electronics manufacturing also needs, or the product needs, a design aspect. So today's topic, we are talking about, how important it is to have the design decisions impact on the ESDM. And what is ESDM? And how this system design plays an important role in the electronics. All these details we are going to talk, and we have an expertise from the industry. You are already aware who that man is, because we have put that in the YouTube link, as well as we also have shared you the poster. Is none other than Mr. Amba Prasad, who comes from Bangalore, the Silicon Valley of India, and with the immense experience in the design sector of more than 30 to 35 years in the electronics industries, whether it is PCB layout, whether it is PCB, multi-layer, high density, high complicated design circuits, you name it, Amba Prasad has an answer for it. So let's welcome Mr. Amba Prasad, the veteran, the most famous design personality from India. Amba, welcome to our show, Global Electronics. How are you this evening?
Yeah, I'm doing very well. Thanks, Rajiv, for giving me an opportunity to be a part of the first launching session. And
Absolutely.
you aptly said that everything starts with design, and even our, I think we are designing not only products, we are also designing our show. So, having said that, why the design is important? As you said earlier, if you don't have a design, you cannot manufacture. The reverse is also true. You cannot keep on designing. So what you design, you should be able to fabricate, assemble, test, and install, and ship it to the customer. So there are upstream activities which happen in designing thermal simulation, signal integrity simulation, schematic entry, what we call as upstream. And then we do the layout. Layout is also considered upstream. And then there are PCB fabrication, which is sort of a midstream. And then there is assembly and installation, test and installation. They go for a compliance testing. That is called as downstream activities.
Okay.
Now, the industry calls it as a shift left or shift right. Shift left means you anticipate things, what can happen in compliance, what can happen in fabrication, what can happen in assembly, and to take care of these aspects in the design stages. And then there are some downstream activities. So no design is perfect. So let me tell you. There will be one or two small nitty-gritty problems with them. That will be cleared at the next rev or something like that, or the lessons learned will go to the company checklist.
Hmm.
Now, here the point is, sometimes even people who work with me, there are so many in this chat room and there are so many in the industry, they got really panicky because I was putting so much pressure on shift left and shift left of left. Actually, I used to, if the schematic is, I used to say 50% schematic is over, why don't you start the layout? And I said, no, I want a layout to be schematic to be 90%. Otherwise, it makes no sense.
Hmm.
And the challenge is when you do a design, especially in a PCB layout, I think, first some 70% happens in 10% of the time, depending on your practices. And the last 30%, and especially last 10%, 90 to 100, takes months together, and everybody gets into panic mode. And that time they try to put more resources, more people. They try to make people work more than, say, normal working hours. We have seen that in the industry, and that leads into some other.
So let me stop you there because that is very good generic way how you described the designing aspects of it, which is absolutely fantastic. But we are talking about ESDM. Now, what is ESDM according to you, Amba Prasad?
According to me, ESDM is electronic system design and manufacturing.
Okay.
When you say system, what it means, it has got only more than one PCB. More than one PCB. In fact, of course, about 30 years back, your XTs and 80s used to have a motherboard, and they used to have a lot of daughter boards. And then Intel came with a SBC, single board computer. So what happened is, what you can put in 10 PCBs can be put in one PCB. Intel came with that formula. But however, unfortunately, whatever 10 PCBs can give you a problem, one PCB will give you the problem. Problem will remain.
So sorry to interrupt you. Just a disclaimer. The guest, when they take out these companies' name, Global Electronics is definitely, held not responsible for any of this usage of name, but it is the pure at the discretion of the guest and, the viewers, who listen to this.
That's good.
So please continue.
So SBCs became a rage sometime back. Then they became a modular systems again. So these ups and downs will be happening. Sometimes people will say, let's have multiple boards in one system so that debug and assembly is easy, observation is easy. Or sometimes they want to put it in one form factor because they want to save space. So in a nutshell, any system design is, it has to be faster, it has to be cooler, which you are an expert in that. And it has to be smaller, and then it has to be cheaper. If you get three of them, if one gets three of them one shot, then very lucky.
So when you said that, what are the major issues that you normally face or see in the system design?
The system design, the system is sold even before the design starts. That's the problem, number one. Because you have to put the system in a very small form factor. Because let's look at some telecom systems or data center systems. What exactly happens is the space is limited.
Correct.
Okay. They want to co-locate as many systems as possible. Number one. Let's say you are doing an electronic system for an automobile. So if you take a classic automobile, the mechanicals will take a lot of portion, and for electronics, they want to fit in any corner which is available. Okay. Even if you go for a EV, people, depending on their perspective, some people say, I want a fast charger, I want, it has to be a safe vehicle. Depending on that, I think it's compartment, it's called as a zonal design. Which zone takes important is very crucial. And one problem I found is, in any design, the power supply aspect is taken for granted. There is a system which is smaller footprint and a smaller volume. In that, they try to pack as much of electronics as possible. I mean, the fancy stuff like high-speed design and protection and whatnot. And then they want to give very little space for the power supply part. And then after, say, 3 or 4 years, they want to upgrade the CPU, or they want to upgrade the memory because they come in their own standard formats, and they start drawing more power. Now they want same volumetric space for the power supply, and they want the power supply to give more power. So that is quite contradictory. Yes.
Yeah. So how do you control that?
Yeah, there are forecasting. Forecasting is possible, and people do a little bit of a robust design. But what happens is, it is a multidisciplinary. Thermal and mechanical is one team. Signal integrity, power integrity is the other team. There's the actual layout person who does it. Then electrical changes keep coming. But they sit across a table, either virtually or in person, and they solve the problem. But finally, one of these 5, I've told there are so many, but I just told them. One of them will take a beating. They have to come out with innovative ideas to how this has to happen. So that's why the other things are evolving actually. Like, today, when we start the thermal management, we thought of only a fan. In fact, the very first system I did for my previous company, the idea was it to be fanless. That was the term, not because of power, because fans, when they rotate, they attract dust. Just dust accumulates. And then you have to clean. And this was supposed to be a class, carrier class telecom equipment which cannot be shut down. And you cannot just do that. And that's why they came with a fanless operation. Then came a lot of cooling aspects like convectional cooling, conductive cooling. Now we are talking of liquid cooling. And every part is improving actually. And now what happens is, this is not a PCB layout alone. It is a multidisciplinary, multi-physics activity. Everybody plays a major role.
No, it's
And
very interesting.
Earlier, at the upstream, I told shift left. In fact, some companies say shift left of left actually. Earlier, this design envelope and the design penalties, it's better. That is really good.
So basically, I mean, when you say earlier means there is a certain period of time that you plan to have that, any kind of, failure mode analysis or anything like that, or?
Yeah, absolutely.
Okay.
So now software is available. Software is available for all this. You
Yeah.
run the software, and most of them are niche software. They are licensed, and sometimes they ask you to share the bill of material, the master bill of material. Some
Correct.
companies don't want to share, and this leads into a lot of other problems. But more or less, situation improved. This is much better than what was, say, you said 35 years back. Now things have improved. Life is become
Absolutely.
easy.
Brilliant. So we have a few more questions, but before that, let's take a small break here for a minute and come back.
Yeah.
Good morning and welcome back to Global Electronics. Once again, your host Rajiv Kulkarni welcoming you from Dallas, Texas. Global Electronics, we have launched that channel today to bring you the electronics manufacturing activities and the challenges and there are many factors that gets engaged in the electronics manufacturing and to bring you the awareness, to bring you the knowledge, the depth of knowledge, the wealth of knowledge that our industry expertise they have to share with us. And so please keep tuning to Global Electronics because you will definitely will have fantastic time with us to know more about what's happening in today's world in the electronics manufacturing area. Welcome back, Amba Prasad ji. Amba
Yes.
Prasad hails from Bangalore, Karnataka state in India. Bangalore is known as Silicon Valley of India, where you find all the high-tech companies, all the designing offices. You name the biggest designing companies, they are based out in Bangalore, and you find the IT hubs in Bangalore, India, which is called as Silicon Valley of India. So Amba Prasad has been in the design sector for the last 30 plus years, and he's a guru of design, we call him. And so for the product to manufacture, designing is the main foundation. And that's why we start with the designing topic. And today we are talking about designing impact or the design decisions impact on the electronic system and design and manufacturing of a product. That is called as ESDM in short. And so coming back to my next question, Mr. Amba Prasad, is how does the decisions of design impact on electronic system?
Very good question. This happens in all other designs. This happens when you build a house also. This happens even when you build an automotive also. But in electronics, it is much faster because earlier I told people want it faster, cheaper, small form factor, and cooler, and at a cheaper price. Okay. See, in the industry, there is a lot of projections are there. There is what is called as early movers and fast learners. And then there are laggards. People say they don't know what they allow situation to overtake them. And this happens in every industry. Now there are some people in the industry, some sector. They learn from fast learners. They don't worry about the fast mover. Fast learners they attack. If you are a fast learner, you get an attack from both the sides because you are above. The first mover will not allow you to climb. Yeah. And these people who try to say we can also do it at a cheaper price or whatever, they are snapping at your heels. So in the industry, being a first mover has got both. It's got a first mover advantage also. It's got a first mover disadvantage also. If some decision, there are so many instances in the industry. You take some bad decision, world will come to know. And there are so many examples. Absolutely. And then the fast learners will he gets in 1 year what the first mover has done in 5 years. That's the market is actually. Then third is, I told you the people, they say, yeah, we can do it. They are a large majority. And they're telling that because of marketing compulsions, not because of anything. Because like any other project, civil or mechanical or anything, people want it cheaper or they want it to be built faster. So these people will jump in and say, yes, we can do it. We have seen a lot of things. Yeah, sometimes they are true, they are fast. Sometimes, generally, in my opinion, is this won't work on a long run. Number 3. And again, this is about where you are operating. Second thing, lot of information available. 30 years back, believe me, Rajiv, when we were taking a data sheet of an IC, even a Xerox machine was not there. Photocopier was. We used to take a sheet of paper, we used to draw the outline of the IC, pin number 1 is this, pin number 2 is this, pin number 3 is this. Wow. And we used to draw it by pencil and say pin number 1 to 2 is 100 mil, between 2 pin rows it is 300 mil. That is a struggle we have gone through. Okay. Even now, if somebody asks me to create a library, I take 15 minutes to create a library.
But let me tell you one thing. We find it struggle in today's world because we have all these amenities available with us,
Okay, I'm
right?
coming to it.
Yes.
So there are
Okay.
three types of information available. Correct me if you know something, you can add that also based
Sure.
on your
Sure.
experience.
Sure.
One is available freely in the website. You put a number,
Correct.
you put a face, it comes free of cost.
Right.
Then the other one comes from the industry itself. You are dealing with a particular fabricator or a particular test and certification company, or you are working with a particular assembly house or yeah, whatever regulatory bodies. They give you a classified information. They take a NDA from you. They give that is the second available. That also again there are so many agencies are there. Their industry is divided. Now even yesterday I was in a meeting with one such agency. I'm contributing for that by the way. So they say we give you know-how, know-why, and we give you the best practices. We can guarantee you can pass the regulatory based on this. We can guarantee you, but don't take this for granted. Everything comes with a caveat. This is a second level of information flow. Now there is a third information flow, which you were telling about 10 minutes back. Industry neutral.
Yes.
Professionals like you and me have learned in a hard way. We are giving the examples, and there are so many industry bodies operating from US, operating from Europe, operating from India. I am a proud member of quite a few of such industry bodies. They give you the in-depth knowledge. But in the industry, what I find is a person who tells you, boss, this is not going to work, is very honest about it.
Mm.
And people who say, yes, I can make it possible, I think it is a bit of marketing or try to capture the market.
Very well said. And what do you think? What should be the key considerations for system design?
System design, in fact, you are asking me to tell something which takes 3 days for me to conduct in one of my certification courses. Yet I'll tell in 5 minutes.
Yes.
The system has got so many features. One is a form, fit, and function. It starts with the board outline. Generally, board outline comes from mechanical. They also take care of thermals. And generally, your customer, I'm talking about a typical multi-board system. The
Correct.
customer wants the LEDs and the plugins and all to in a particular place. These are all covered by industry bodies. And generally, power supply entry will be from the back. People don't want to fiddle around with the power. Now, as I said, 30% of the space is gone for the power, and another 30% is gone for all this industry stuff, which will take its own footprint. Now, you start with a PCB. A PCB has got a sliding space, it has got a fixing space, it has got so many things. The real estate, what you see in the board outline, and what you get for the actual silica, the physical components is almost 50%. Yeah, we had a thumb rule even 30 years back. If you can put a components, 80% of the components in the board, layout is possible. And this was 30 years before surface mount technology came into consideration. But when surface mount technology came into consideration, we were able to put components on both sides of the board. And today, we are putting components even inside the board, embedded components.
Oh.
It's very different challenges. So one is form, fit, and function. You should be able to fit everything within the envelope, design envelope. I'm talking about a system. And then you should be able to upgrade easily. Schematic versus layout, there should not be no error. These are the very hard errors. Okay. Then comes the soft errors or soft requirements. Signal integrity, power integrity, acoustic noise, thermal. Some people think thermal is a hard, but I think thermal is a soft, because you make a system which is cooler, which is faster, which is power efficient, and which is mechanically wrong. You cannot insert in the chassis. You realize after 100 boards have been built, then again you have to go for an next rev. And this, let's go for a next revision, brings a very, lethargic attitude in the design team. Once they know there is a backdoor, they don't take it serious. There are so many boards which have taken 3 weeks more, 4 weeks more, even I'm very proud to say boards are working in the first revision.
Excellent,
But
excellent.
company paid a price of 1 week extra and 2 week extra. And people are told, they are told in privately, of course, in lifts and corridors, Amba, how it is possible? What you can see, what I cannot see. So what's happening is when you do a layout, even a mechanical drawing, you do a layout, you do simulation, the person
Right.
standing behind you on your shoulder, he can see something, quickly what you cannot see. Their feedback is very important. The peer level review, especially the critic part of it, it is excellent. And you can develop your own checklist based on that.
Excellent, Amba Prasad. I think we are almost now coming to the end of the session. And what do you think the role of these education and certification of these industry bodies? Just from
Okay.
your
Before that,
because you're an expertise in that.
I'm a
You're
trainer.
part of So
I'm a trainer myself. See, there are, before that I will tell you, nowadays, because of, unfortunately, what happened is the AI and ML came to assembly. Assembly companies, EMS companies have already taken AI and ML. They have gone for a model building. They have gone for Industry 4.0. They have gone for connected factory initiative where the machine feedback, it comes to you on a real-time basis. And the PCB fabricators
yeah,
and designers very slow to pick this up. So to make it AI and ML investments happening in a assembly segment, if designers don't consider downstream also they're responsible for that. It is not you do design and you just transfer it. It is the designs become real time. Now many CAD companies will allow you that. They give you real time DFM checks.
yeah,
You can just get the data, do it, and make it happen. So that's number one. Coming to education, education is very, very important. There is like what we are doing, like global, we are doing now. This is just an awareness program. Now people
correct,
know that
correct.
schematic versus layout is very much important. They know thermal is important. They know all that stuff. However, these are all very low hanging fruits. Then comes the data which comes from the fabricator, which comes to you after NDA side. They give you reference designs, or they give you the design envelope. They do all that stuff. So that's important. And sometimes reference designs, they do over provisioning for certain things that can be compacted in the next round. That's not an issue. And then comes some stuff which is available on website, which is slightly dangerous. People put all. I mean, I'm not telling it is dangerous, but I think whatever comes without any caveats.
From the IP perspective, yes.
IP perspective.
Yeah.
Then comes your education and certification. Education, especially after COVID, lot of industry bodies, which whom I am associated with, even the other industry bodies, they came out with a training on virtual, which is you don't have to travel. You can just register and you can get educated. You get a certification of completion. They ask you a quiz. You have to ask 50% of the questions properly. Then only they give you. That is, you get a lot of education. That is there in all aspects. That is there in signal integrity, power integrity, thermal, DFM. You name it, it's available. And then there are certain statutory documents. Now, for example, I just tell you, if you go to a PCB material data sheet, all data sheets from even the competing companies look similar because they are supposed to comply to a particular format. Otherwise, every vendor would like to highlight where they are good at it and whatever they are not so good, they try to suppress. That's not possible. That is where the industry bodies come into picture. Industry bodies, for any standard to pass, they require 85% of the voting. Then only it will pass. There will be a lot of dissents. People don't get access to the dissent. What we have, I would always like to see the dissent part of it. I learn a lot from that. Number one. And the certification. When we certify a person for fabrication, for assembly, for cabling, and for even design, we watch by it. Not only that, we train on 35 people. If they get a problem, we are there behind them to solve the problem on real time. So
Correct.
this is where certification plays a very key.
Excellent answers and excellent explanation, Mr. Amba Prasad. I think we are almost to the end of the session. 30 minutes. We have covered quite a bit today in the design aspect of ESDM, I would say. But of course, design, I'm just telling the viewers, design is a vast subject. It's like an ocean, and there are multiple things are engaged in the design areas. Today we have covered the design decisions impact on the ESDM, that is electronic system design and manufacturing aspect of it, and that too we have covered a little bit in 30 minutes. Definitely, if you want more and more uh, in-depth knowledge about these ESDM designing aspects, you can always get in touch with Mr. Amba Prasad. He should be able to give you a one-to-one, a design consulting and also design suggestions. And
Yeah.
for his contact, you can always get in touch with us, Global Electronics, and we will put you guys in touch with Mr. Amba Prasad. Amba Prasad is
So
based in Bangalore, Karnataka, in India. Yes, Mr. Amba Prasad.
let me tell you only a long sentence. I contributed for 4 roadmaps last year. 4 globally recognized roadmaps. I contributed for 1. I gave them 14 design aspects. They
Wow.
got it clear checked by another road mapping. They told 11 of the 14 is our problem. Why don't you come and participate like that?
Absolutely brilliant.
And this is, as you said earlier, sometime that this is non-branded, no, campaigning or making fun of somebody.
Correct.
And this is what happens now, what happens after 3 years, what happens after 5 years, what happens for 10 years, showstoppers, gaps, and challenges. I'm
Excellent.
telling you, even after 10 years, I'll be sitting in one of the meetings again deciding what happens after 3 years, 5 years, and 10 years.
So I think
That's
that
how
is
it
what
is.
the cycle, we always keep following. We never knew 30, 40 years back the technology advancement will be so intense and immense. And so the design aspects will be so interesting. So with that said, for the next week, next Friday, we are going to come back with again Mr. Amba Prasad talking about signal integrity designing. So that is the most one of the most important factor in the design of the electronic system, I would say. And anything that you want to know about signal integrity, definitely you are welcome to be prepared with the questions. And Mr. Amba Prasad will be here to answer your questions. So keep tuning with us and our channel Global Electronics, and please share the link. Please share the channel with all your friends and contacts and everybody, so everybody can get benefit out of it. Amba Prasad, thank you very much for your time today. So we are going to see you again next Friday at the same time with one more session of signal integrity. You have any questions?
Only one statement I have, not
Yes, sir.
question.
Yes, sir.
The very meeting what we held and the very recording people are going to see now and forever is because of electronic system design and manufacturing.
Absolutely true. Absolutely true. That's a beautiful sentence to end with. With that said, I thank you all for watching this show, and please be with us next week at the same time and with our same gentleman, Mr. Amba Prasad, for yet another session of electronics system design, but with the signal integrity design. Thank you all, and have a great evening, great afternoon, or a wonderful day wherever you are. Thank you.